Hi, Professor Bob Young here, and in this instructional video, we're going to look at vertical and horizontal lines, parallel and perpendicular lines, and then let's just do a general graphing technique, a review of all the different equations and forms of lines. All right, so looking at this supplemental handout that y'all can get in Angel or were handed out in your lecture or hybrid courses, notice the bottom right box has parallel versus perpendicular lines. And notice it says parallel lines have the same slope, while perpendicular line slopes are negative reciprocals. All right, so parallel lines are designated by the symbol here, and it kind of looks like some railroad tracks, so we'll pull that up in red. So it says two distinct non-vertical lines are parallel if and only if they have the same slope. So in other words, let's say if I took a slope of a line and I gave you a slope of a line was 2/7, the slope of the parallel line would be 2/7 as well. All right, if I gave you a slope of a line of -5, its slope of the parallel would also be -5. Now I know what y'all are thinking, Young, there must be some trick here. What's the catch? There is no catch. Now, perpendicular lines, if you remember your old high school geometry, they are two lines that form right angles. All right, so that's an old geometry formula. So notice here it says two lines, neither which is vertical or perpendicular, if and only if their slopes have a product of -1. Thus, the slopes of perpendicular lines, neither which are vertical, are negative reciprocals. So we talked about that in the major handout here. So in other words, if I gave you a slope of, let's say, 4/7, the slope of the perpendicular would be the negative reciprocal of that. So you have to take the reciprocal of the fraction 4/7, which is 7/4, and negate it. Another example, if I gave you, let's say, a slope of -14, the slope of the perpendicular, well, would be the negative reciprocal of that. So it would be 1/14. And again, notice the sign changes. So if we multiplied the slope times its perpendicular slope, we would get a product here of -1. Continuing. Next, we're going to write some equations of lines, which we've done in previous videos. But this one says find the equation in slope-intercept form of a line that passes through the point 3,5 and satisfies the given condition, parallel to the line 2x plus 5y equals 4. So I think y'all know what we're going to do here. We're going to get the equation writer out here. And what we're going to do again is, given this line here, we're going to have to go from standard form to slope-intercept form by solving the equation for y. All right, so if we get y by itself here, and I'll go ahead and get my colors out, we're just going to subtract 2x from both sides, divide each term by 5, and notice we have the slope of -2/5. All right, now down here on the bottom it says, well, the equation was here, the condition was, well, the slope had to be parallel to this given line. So notice since we came up, once we changed this to slope-intercept form of a slope of -2/5, well, the slope of the parallel line must be -2/5. So they're going to try to pull your chains all kind of directions with these parallel and perpendicular lines. All right, so let's go ahead and plug all this in the equation writer. We'll go ahead and put in x1, y1 for the point. We'll label it. We know we found the slope of the parallel was -2/5. All right, and it's plug it in time. So we get y minus y1 is y minus 5 equals -2/5 times x minus x1 is x minus 3. Distributing, we're going to get -2/5 times x is -2/5 x. Negative times negative will give us a positive, watch those signs, 6/5. And then I think we're just going to have to add 5 to both sides. So adding 5 to both sides of the equation here, we will get the line that's parallel to what we were given. All right, now I know what some of you are thinking, Young, how do we go from 6/5 plus 5 to get this 31/5? Well, you have to be able to add fractions, ladies and gentlemen. So I'm just going to change 5 into a fraction, 5 over 1, get a common denominator, or you could just punch this in your calculators and they would give you the same thing. First fraction, don't have to mess with because it's already the common denominator. Second fraction, we have to multiply top and bottom by 5. So 5 over 1 in fifths would be 25/5. And I hope you all see now where they get the 31/5. Could you check this? Could you check this equation? Yes. If I take this point 3, 5 for x and y and plug it in down here, it will make perfect sense. So in other words, if I take negative 2/5 times the x value of 3, add 31/5, if I did this right, y should come out to be 5. And it will. I'll let you do that check to see. All right, now let's do one more like this one. Find the equation in slope-intercept form of the line that passes through the point 3, 5 and satisfies the given condition. Now notice in this case it says it has to be perpendicular to the line 2x plus 5y equals 4. All right, now it says we know the slope of the line, okay, because we found this earlier. We found the slope of the line solving this for y in the previous examples was negative 2/5. So notice what they're saying here. Well, the slope of the perpendicular then would be the negative reciprocal 5/2. So be careful there. It's kind of the same thing we did, but we're just going to use a different slope. So here we go again. Y minus y1 equals m times x minus x1. So all we did was change the slope from being the same parallel to perpendicular here. Distributing, 5/2 x minus 15/2. And adding 5 to both sides gives us the slope-intercept form of y equals 5/2 x minus 5/2. Now again, students, I don't know why, have trouble with adding negative 15/2 plus 5. So make that 5 over 1, get the common denominator of 2, go from there. It's vertical and horizontal line time, ladies and gentlemen. And so an equation of a vertical line through the point AB is x equals a. Now this is how the book presents it. An equation of the horizontal line through the point AB is y equals b. Or actually, it's how most books present it. I know what some of you are thinking, Young, that makes absolutely no sense to me. So let's show you what we mean by this. Let's find the equations of the vertical and horizontal lines through a given point. Let's take negative 3, 7, which I'm going to come up here and plot in pretty red. All right, now if we want the equation of the vertical line first, I'm just going to go ahead and run a vertical line as best I can. I'm getting my old line tool out here through there. That's not too bad, okay? And notice if I'm at this point, and I'm going to stick it up here, negative 3, 7, so it's out of the way, the line goes through which axis? It cuts the x-axis where? Well, at negative 3. That's the x part of that ordered pair. And remember, we've talked about lines like this. If the line is vertical, its slope is, do you remember? Undefined. Undefined slope. All right, and now let's do the other one here, the vertical line that goes through this. I'm going to take another pretty color because y'all know I like to use my colors here. Let's take a pretty blue, and I'll try to get the line tool out here. I must have missed hitting the line tool. This is what happens when I hit and miss in the line tool, so that's going to have to be close enough. But notice here again, if it's vertical, which axis does that line cut? Well, it cuts the y-axis where? At 7. All right, so that's what that graphic before this was saying. And what is the slope of a horizontal line? Well, this one would have a slope of 0. That's the one you don't want to be on a heart monitor on. All right. Let's graph the lines here. Now, they might just come right out and give you the equations. Graph the line y equals -2 here. Now, most of you would know that y is -2 down here. All right, but there's no line. That's just a point. So if you wanted to, on part A here, you could make a little list of ordered pairs, and no matter what x is, y will always be -2. And then you can put any x values in you want there. And that'll kind of help you if you're not sure which way the line's going, if it's vertical or horizontal. See, so y is -2 all along this spot here. So I'm going to hopefully get the line tool out. And oh, that one looks a lot better. Yes. So any line that's horizontal is going to cut y. Now, x, b, and 3, let's go to a different color here. X is 3 here on the x-axis. And if you're not sure, again, well, I'm not sure if that line's vertical or horizontal, young, I forgot. Make a little table of ordered pairs, and we'll just put 3, 3, 3 there, and you can put in anything for y that you want. And notice x is going to be 3 all the way up and all the way down this area. So getting the line tool back out. Now, I know what some of you are saying, Young, put some of these on the test. I just might. A horizontal or vertical line. All right. So this one would be x equals 3. So any vertical line will cut x. Any horizontal line will cut y. All right, so let's just run through some review here and talk about some things. So here's the equation slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Am I going to give you all these on the test? No, I want you to know these formulas. So maybe take an index card and stuff and see what is the best time to use them and when not to use them. When to use, easily identified and used to quickly graph an equation, because remember, you start at the y-intercept, use the slope. And then the equation writer, the point slope form, ideal for finding the equation of the line, given a slope and point. And we've been through many of these. So a little review here. Standard form. Now, this is easy to graph if you can find the x and the y-intercepts. If you just let x be 0, solve for y, let y be 0, solve for x, those will be your 2 points. And it gives you some other information in the description there, what happens with the slopes and stuff. But we've talked about those as well. And the lastly but not leastly, y equals b is the horizontal line, x equals a is the vertical line, and we just got done talking about that. Now, one last thing here. Let's convert. I tell you what, we'll do one thing here just to tie all of this together. All right, I'm going to go back to my main handout here, and what we're going to do in the last minute or so of this video is I'm going to take and convert all 3 of these forms. Now, usually we start with the point slope form. Let's say we get the equation of a line in point slope form, and we want to change it to the other 2. We're going to change it to slope-intercept form and standard form just for good measure here. All right, so let me clear this off here, and I'm going to go ahead and take an equation here in point slope form. I'm going to say y minus 2 equals negative, well, let's call it positive 1/3 times x, let's go plus 4. All right, would y'all agree this is in the old point slope form? Well, I certainly hope so. So there's not a lot of equations here and so forth, so let's get to know them. All right. Now, let's say we want to change this into slope-intercept form. Y'all got your hand out there? what does it say to do? Now again, know your form here. This is y minus y1 equals m x minus x1. If we want to go to slope-intercept form, we've got to solve this equation for y. We've got to say y equals mx plus b. So that's what we're going to do here, just to show you that these three forms for the equation of the line are, you can interchange them. So distributing, you're going to get y minus 2 equals 1/3 x plus 4/3. And we've done a bunch of these. Add 2 to both sides. And y will equal 1/3 x plus what? Now, if we change 2 into 2 over 1, get a common denominator of 3, multiply top and bottom by 3, we will get 2 over 1 is 6 over 3. So that'll be 10 over 3. So we have just gone from point-slope form to slope-intercept form by solving for y. Now, what if we want to change this to standard form? All right. Now, notice standard form on your handout. You can't have fractions and decimals in standard form. And we'll come over here and put it. And sometimes they ask you to put them in different forms and different classes and stuff. ax plus by equals c. So I'm just going to subtract 1/3 x from both sides and get the x's and y's on one side of the equation and the number on the other. All right, so in standard form, remember this a number here, and Young just did that on purpose to be mean. This a number, you want to keep it positive, and you don't want any fractions or decimals in it. So what I'm going to do is kill two birds with one stone. I am going to get rid of the fractions by multiplying through by the LCD, which I hope most of you see out there is 3. And I'm going to get rid of this negative sign by multiplying by the opposite of 3 to get standard form. And what I'll end up with is a very nice positive 1x. I got rid of that negative in front of that a number there. It's positive 1 minus 3y. Now notice the b and c numbers. It doesn't matter if they're positive or negative. Just that a number they want to keep positive equals negative 10. The 3's would chop out. All right. So which one do y'all like better? Here's 3 different ways to write the same line. We've got over here point slope form. We've got here slope-intercept form. And we've got here standard form. All 3 represent the same line, just written a little differently. And the information, you can get from each is a little different. And you can use them a little different ways. So Bob Young signing off. Have a good one.